So 6 transistors in the car, and if you fast forward today, how many transistors do we have in our car? How many switches? 300 million, a billion, so a whole lot more. So that means all the electronics systems have evolved significantly, and so have the tools. So if we go back in time, start looking at the beginning of electronics design. We talked about maybe in the 80s, we had the initial products like board station and so on, that were more like the basic capabilities of schematic and layout. You had a couple of automation functionalities in there. And with the increase in design complexity, also the increase in tools and in platform needs increased. So that means we have started in the 90s and early 2000s to bring more design automation into the tools, like Expedition and like the advanced functionality, working more concurrently, collaboratively in the engineering department. Fast forward in the 2000s, 2010, 2020s, we had even a further increase in complexity. So you had multiple boards that had to be integrated into a system, and that means you had to have functionality to manage connectivity across multiple boards. So that was pretty much the beginning of multi-board design systems and how to establish interconnect between the different domains. The reason why I'm telling you this is because as we are going into the presentation, you will see how we are going to take this to the next level. But in parallel to the business goals that you typically have, that companies have, like time to market, like cost improvements, like productivity improvements, you're dealing with a whole lot more challenges in the recent past. And definitely the situation starting in 2020 has accelerated that. So we talk about areas like sustainability, like resources, and so on. I take a couple of examples in the presentation to explain to you how we are seeing these things, these drivers in our customers, demanding for new methodologies to create and develop electronic products. And so the first one I want to talk about is the demographics. I think it's not a secret that a lot of engineers and a lot of PCB designers are pretty much either retired or retiring. So that is a trend that is going on for the last 10 years or so, that we are seeing a lot of the very senior people are looking into retirement or have retired. On the other hand, the difficulty that our customers are dealing with is to find new talent. Based on market studies, we found that about a third of the engineering positions will not be filled in the recent period, in a very short period of time. That means you're competing with other companies for getting talent. It also means that you have to do potentially more in electronics design as the products are getting more complex with less people. And you have to make sure that the young engineers, the young talent that is joining your organization is going to be trained faster and coming faster up to speed, because you don't have the luxury to wait until they have 10 years or 15 years of experience to be an EMI designer, a mechanical engineer, a PCB engineer, having experience on signal integrity and so on, and manufacturability at last. So there is a lot of things that young engineers need to learn, and they need to learn them quickly. So that's a big driver for our customers. The second driver we are talking about is the development cycle and the life cycle. I don't know, I was just visiting my mother a few weeks ago, and she has a washing machine that is some 30 years old. I don't know if you believe that washing machines in these days will have the same life cycle because there is an innovation cycle, there is power savings, there is additional functionality, water savings, sustainability, new criteria that are coming online that are driving customers to drive change and to buy new products. So product life cycle, the product life cycle within the customer is significantly increasing. But then in addition, the other factor is, of course, development cycles are reduced significantly. If you think about the amount of time it took in the past to develop an aircraft or to develop a car, let's take a car, for example. I think it was 8 to 10 years to bring a new platform. That has significantly been reduced to 2 to 3 years. So there is a lot of pressure internationally to make sure that you're staying on the most innovative platform and deliver products much faster into the industry. The third item that is challenging us quite a bit is the economic situation. If you look at some of the economists, they say within 5 years, we have gone through a lifelong change, a generation-long change in the industry. And there are a number of changes. On one side, electrification is a big challenge. When you think about sustainability and electrification, there is a lot of drive in the industry, on the customer side, in the market, to get new products faster into the market that are more effective and more sustainable. But that is just one area. When you think about the fact that starting with COVID, we had significant challenges to get components. It's really something that kept our customers very, very busy and consumed a lot of engineering resources to make sure that you overcame the component situation. So the markets have changed quite a bit, in addition to the fact that, of course, you have all these geopolitical challenges that are coming over and over again. So it's not just an event, it's an ongoing process that our customers have to deal with to make sure that the unpredictable situations in engineering can be addressed very dynamically and swiftly. So that is an important point for why we believe these are some of the 3 new challenges that our customers have to deal with, besides their standard corporate initiatives like cost and productivity. So going back to the initial slide, we talked about the situation starting in the 80s, going into 90s with next generation, and then now design automation and multi-board systems in the 2000s. So what is the purpose of a next generation electronics design system? We are really looking into making sure that we're helping our customers to address the challenges that we're seeing coming more and more on the horizon. When we talk about next generation electronic design system, we really talk about something that is not only integrated with the Siemens accelerator portfolio, so you have the ability to establish the thread, the digital thread of data from design definition down into manufacturing with automation, AI, and so on, but also to make sure that we are helping our customers to overcome some of those demographic challenges and to accelerate the innovation cycle in electronics engineering. And so Siemens Accelerator is the platform that Siemens is promoting as the overarching solution across all domains. But in addition, of course, our objective is, and our mission is that we are going to stay open for other integrations, like other PLM systems, like other mechanical systems, supporting standards, driving standards that are going to help our customers. So when we talk about the next generation electronics design system, we pretty much talk about four properties that we are focusing on. The first one is the ability to be adaptive. Adaptive to the user's behavior. Not every user is working the same way. Everybody has their own style. They have their own color scheme, their own skin, their own experience. So we want to make sure that engineers have the ability to much quicker adopt new capabilities and learn the best of the tools in a very short period of time without having to go through extensive training or through reading manuals. That leads to the second point, efficiency. So when we talk about efficiency, it's also related to the experience that the user has and the ability for our tools to see, based on the designs, based on the capabilities that the customer is using, the user, what other functionality would be valuable for this particular user in order to be more productive. So getting the tools in use as efficiently as possible, and also for you as a customer to make sure you get the maximum capabilities out of your tools that you purchased. So making sure that we are driving that efficiency across the entire organization within engineering and across engineering with adjacent organizations. And that leads to the third point, collaboration. So when we talk about collaborative, which is the third pillar, we want to make sure that we are not only enabling collaboration within the organization, but having a secure collaboration with external partners. And when we talk about secure collaboration, it means the ability to share information, to redline information, to trace information, but also to make sure that you have the rights to use that data or to access the data. And that leads to the fourth pillar. The fourth pillar is the fact that we want to make sure that it's secure. So when we talk about managed, we talk about the ability to manage your environment, but also to manage the data in a much more secure fashion. And specifically when we talk about secure fashion, we have these days, a lot of issues with in the industry with cybersecurity. I was at a customer a year ago who just switched to our solution, and they were about to deploy, and they got attacked by in a cyber attack. Can you imagine an entire company with 2,000 or 3,000 people being down for almost 2 months because they were attacked and all the computers were blocked and blocked with ransomware? This is a challenge that everybody is dealing with. And the IT security department is, of course, asked to work on the overall IT side, but we have to make sure as engineers are sharing data with their partners or within the organization that they have the right and they have the ability to access this data securely. So when we talk about those 4 properties, they're built on pretty much on 5 pillars that you will see throughout the presentation and that I will highlight here in the next slides. So we talk about intuitive, and you heard already from Ibrahim, when we talk about intuitive, it means a lot in terms of AI-driven information and AI-driven user experience and the acceleration of usage. Then AI-infused, as I mentioned, we talk about cloud connected. So having a connected desktop means you have to also be able to connect to the cloud with your external partners securely. And finally, of course, integrated. And integrated, I have a couple of examples that are really exciting on the way how we are able to build an integrated digital thread across the Siemens organization with our partners from the capital side, with the partners on the mechanical side, with Teamcenter. So there are a number of very interesting capabilities that are part of this next generation platform. And of course, the secure, as I mentioned. So let me take those examples in detail. So we talk about intuitive. One area that we spend a lot of time in is the user experience. And if we go back to the current user experience that we have across our tools, it's not very consistent because the schematic operates slightly differently than the layout. The simulation and verification tools operate differently. So we went on a mission about 3 years ago with external partners, external consultants on user experience, and said, okay, what is going to be the user experience for the future? Not for today. We're talking about what we need in 3, 4, 5 years when engineers are going to be challenged with not having the depth of skills they come fresh on board. So how can we make sure that we are going to help these users to become productive as quickly as possible? So that is how we built the next generation user experience within the expedition, the paths, the hyperlinks, and the Valor platform. So all of them will look the same. They will have the same user experience. And of course, the objective is that we are minimizing the effort to learn, to relearn, and specifically when you have users that are occasional users, to make sure that we are going to give these users a very quick re-entry into the tools. Sorry, I didn't mean to have audio running, but so pretty much what we have done is we have put that user experience consistently across all tools from EBS. Valor, Hyperlinks, Paths Professional, Expedition, the Designer, the Layout, Valor NPI, Validate, IO Optimizer, all the tools that are in the flow are having the same user experience. And that means it's easy to learn, it's easy to relearn for engineers to get up to speed very quickly and to customize to your own needs. Think about you have a new user you don't want to overwhelm with all the new functionality in the tool, everything that is available. So we have the ability to say, I have a skin for beginners that has only a subset of functionality. And you can configure that to the needs that you have as a user. So that is the ability to make sure that we have a very adaptive user experience, even for people with disabilities, focusing on the needs of people that are colorblind, that are disabled, to make sure that they can use the tools more effectively. So a lot of effort went into that to make sure we have that consistency. The other one that Ibrahim mentioned in detail is AI infused. And when we talk about AI infused, it does not mean that we are going to press a button and say, hey Google, I need a motor controller that is working on 18 volts for a vacuum cleaner and should be an ST32 platform. That is not realistic, because you need to have all these different constraints put into your design that are company proprietary. And of course, you have to make sure that the results are verifiable. If you think about the AI, if AI would synthesize a design, it would be very difficult to verify that it's going to meet exactly the specification, the needs for inspection, for quality, for reliability. These things are not necessarily verifiable if you would synthesize a design. If you want to train an algorithm to synthesize a design, I don't know if you are familiar with how many designs you would need. It's about 1 million. 1 million designs to make sure that you can synthesize a design. When you think about 1 million designs, where would they come from? Everybody has to chip in. Everybody has to upload their knowledge into the cloud, share it with everybody else, like ChatGPT. Do you want to do that? Does your company want to do that? Probably not, because you have a lot of IP that you do not want to share with your competitor and with other customers in the industry. You don't want to have somebody in China being able to participate or benefit from the knowledge that you have put in the system. So these are the things that we are focusing on, making sure that our AI-infused technology is leveraging AI to support the engineer to be more productive. And as Ibrahim mentioned, we are breaking this down into 3 categories. So we have the adaptive, the additive, and the assistive methodology. And each of those will have their own experience, their own roadmap, at a new functionality that's coming online on a regular basis. So we start, as you saw earlier, with command prediction. And let me see if I can turn off audio here. So when we talk about in AI-infused and predictive commands, the way how it works is the knowledge, the training is happening on the user's desktop. Has nothing to do with the cloud. So when you think about the predictive command functionality, it is stored on the user's desktop, if you want to share this prediction, this training with other users, you just copy that file within your company from one computer to another. So that is a user-specific capability. There will be other functionalities in the future, like constraint prediction, component prediction, placement, and route prediction. These will be stored on your server. We will not use the cloud for these capabilities because they include a lot of company proprietary information. So from that perspective, we are making sure that whatever we are doing in terms of AI is going to respect your company's IP and is going to leverage AI to improve the productivity of your engineers. We talk about cloud-enabled. Cloud-enabled means, of course, you want to collaborate with internal and external partners, and that we have collaboration capabilities in the cloud within our enterprise data management solution, and also like this capability here that is available with Paths Professional and with Expedition. And when we talk about cloud capability here, I want to give you one example, and it's the intelligent part list. So if you look at the components that you're putting in your design, you want to make sure on the engineering desktop, not when you start to go into sourcing, on the engineering desktop, to understand what is the risk using that part. What is the risk in my BOM when I use this part over another part in terms of do I have all the properties? Is the part available? Is the part available from my preferred distributors? Is it within the cost envelope? Is it end of life? Or is there a risk that it may be end of life by the time I'm going to use it in my production? So these capabilities are also driven by AI. So we are using a lot of data from SupplyFrame, our partners within Siemens, and SupplyFrame has this information with 20 million market signals that are coming every day, in addition to the component information data. So there's a lot in that area coming as well. So the next one is the integrated. And when we talk about integrated, we are focusing on the digital twin. So really how to bring the different domains together, because that is one of the key challenges that we hear from most customers. Having electrical and mechanical design working closely together without sharing just a static file. And so the way how we do this is by making sure that we are going to have an IDX file on the mechanical side, but also on the requirement side, something that is providing you with a digital traceability of requirements from the requirements management system down into the domain, where you then can enable your engineering team to verify that you are implementing those requirements correctly. So I want to give you a short video how that looks like. So we read in requirements file, could be from doors, could be from something else, and that is going to show the hierarchical requirements. The engineer then is going to put a test plan together, say, I need to make sure that I verify that particular requirement in my design. So if the requirement fails, of course, you have to make adjustments to the design. In this case, we just cheat a little bit by saying, the creepage should be 25 mil, and we reduce it to 12 mil to show you what the difference looks like in that demonstration. So once you meet the criteria, it marks the requirement as completed, as passed, and that then can be propagated back to your verification management system. So that is the first digital thread. Architecturally, making sure that we are going to track requirements into the domain, really going down the V with the requirements, and make sure that those requirements then are going to be verified and tracked. The interesting is, of course, it was hard to see in that video, you have also the full traceability. You know exactly who did when, what kind of verification at this design, and changed the status of that design. So you have that full traceability in your system that can be also propagated back to your verification management tool, so you have a full documentation of your design. So when we go through all these digital threads, I want to emphasize again the mechanical digital thread. And this is an example for an electromechanical digital thread where we are bringing the electrical, the mechanical, and the electronics world together. And this is a video that is showing how you go into the system, run with SimCenter, you run an analysis on that connector and say, okay, I want to make sure that I'm not exceeding certain runtime in my design. So this is what we do in SimCenter. Then the electrical engineer or the electronics engineer goes in and changes the connector based on what they get from the mechanical side and what they get from SimCenter. They update the connector, and that connector, as it's going to be updated on the electronic side, is then sent as an incremental change to my mechanical engineer. The mechanical engineer verifies if that change can be implemented, if that meets their criteria like form factor, building space, and so on, and then implements that on the mechanical side. From here, we are going to update the electrical side, saying, okay, we changed the connector on the mechanical side, on the electronic side. Now we got to make sure that on the harness, we have the right connector. So that is the digital thread that we are building together with our colleagues when we talk about not only electronics and mechanical, but also electronics and electrical collaboration and working with the other domains. Then the other part is just to close on the digital thread. When you think about the fact that quite often you have a very complex system. You have an LRU, an electronic system on one side, you have a harness going through your equipment, your airplane or your car, and then you have an electronic system on the other side. How do you make sure that you have the ability to track your signals and your signals across the domain? Not only within the domain, not only going from one board to another, but how can I track a signal from one LRU through the cable to the other LRU? And that's where we work very closely together with our colleagues on the Teamcenter side. And we have put okay, so no audio, good. We have put a solution together with a common, an enterprise Siemens-wide ontology project. That means we are looking at what are the different things, what do the different things mean in different domains, standardize that, have teams that are orchestrating the inquiry that you can do then, going from capital into expedition, and really have the ability to track your signal across the connectors, make sure you have the right connectors, you have the right pins, and you have the full traceability across the entire system. So that is a project that is coming online very soon. On the ECAD-MCAD side, real quick, we have not only done the electromechanical collaboration, you also want to make sure that you have the ability to track your components across your entire supply chain, and to have the ability to make sure that if you have different orientations on your mechanical, on the electronic side, that your mechanical system is following. So you have one representation of the component on the electronic side, and that is synchronized with the mechanical side. And finally, when we talk about the security, that is where we put a lot of effort in based on some of the military customers that we have. And the military customers give us some great examples on how to make sure that we are able to trace signals and to block users from unauthorized access. Let me run this video for a second for you. Oops.
Brooklyn and her team are working on a very important project. To enforce US export control legal restrictions, this sensitive project was started in Icon Town. Only American users that are located in the US are allowed to access this project. Brooklyn is an American citizen and she is located in the US. Therefore, during login, EM plugin server assigns Brooklyn with the access restriction tags. Last week, Brooklyn traveled to Mexico for a customer visit. As she remotely logged into EDM to learn about the progress of the project, she could not find a sensitive project listed in EDM design copy. Her session had no known doubts. EDM Collaborate was no different. The project wasn't there. A check with the admin confirmed. Data access restriction tags are dynamically assigned to users based on their current location, and therefore she cannot access the sensitive project outside of the US.
So that is pretty much the summary of all the capabilities on a high level that we are going to bring with our next generation electronic systems design solution. So we're talking about intuitive new user experience. We talk about AI infused across different areas, whether it's component engineering, simulation, optimization, but making sure that we are helping engineers to be way more productive. We talk about collaborative in the cloud. We talk about the capabilities that are working on the digital thread, and we make sure that it's secure. That is the new platform that we are bringing out here, and it's coming in the second half of this year. That is the Expedition PATS Professional Hyperlinks Valor Next Generation Electronic Systems Design. With that, thank you very much. And as I understand, there is a break outside, so make sure you get some coffee before and get some refreshments as we're going into the next sessions. Thank you.